Welcome to Vision International School. Today we explore the world of polynomials.
Welcome to the beautiful world of polynomials. Today, we will unlock their secrets. By the end of this class, you'll see them everywhere. Are you ready to begin? Notice the perfect parabolic path of the ball. Gravity pulls it down, creating this curve. Imagine a world where your mobile phone connects YouTube, cricket, and pure technology. From massive bridges to a video game world, this is the future.
Notice how these elegant curves are not arbitrary. Every arch is a perfect calculus function.
The stress vectors here match the blueprint perfectly.
This is where mathematics meets reality. Welcome to the future of active learning. Every movement leaves a glowing motion path. These trails help us track physical performance. This is where gaming meets physical education.
Welcome to the world of modern animation. Here, every movement is controlled by precise mathematical curves. By manipulating these arcs, we create life. This is where art meets technology.
Observe the trajectory on the main screen. Escape velocity requires precise thrust. We are breaking the bonds of Earth. When we look at historical data, we see how patterns change over time. This volatility often precedes a period of substantial growth.
Observe the perfect arc. That is mathematics in motion. From gaming to rockets, polynomials are the hidden code that moves our entire world.
Welcome to Vision International School. Let us begin.
Students, what did you see in this video? Cricket, rocket, bridge, business, AI. But tell me one thing, are cricket and rockets related? No. Are bridge and AI related? No. Then why did I show all of them in one video? Because there is one hidden language working behind all of them. That hidden language is mathematics. And one very important part of mathematics is polynomials. Students, today I want you to discover three important secrets. What is a polynomial? What is a coefficient? What is a zero? Today we are going to open these three treasury boxes one by one. And once you understand these three ideas, the entire chapter will become much easier. So, are you ready to enter the world of polynomials? Students, before we understand polynomials, we must understand the building blocks. Look at this gate. This gate is called polynomials. Before entering this gate, we need four important steps. The first step is numbers. Numbers are the basic materials of mathematics. The second step is variables. Variables is letter whose value can change. The third step is coefficient. A coefficient is a number attached to the variable. The fourth step is powers. The power tells us how many times the variable is multiplied by itself. Students, can we construct building without a foundation? No. Can a tree grow without a seed? No. Similarly, we cannot understand polynomials without understanding these basics. First, understand the building blocks. Strong basics build strong problem solvers. Now let us start with the first building block, numbers. Students, today we are starting chapter 2, polynomials. Before solving any questions, we must understand one simple thing. What is a polynomial? A polynomial is a mathematical expression made using numbers, variables, and powers. Look at the first example, x plus 2. Here, x is the variable and 2 is the number. Look at the second example, x square plus 3x plus 2. Here we have variable, power and numbers. Look at the third example, x to the power of 3 minus 5x plus 1. Here also we have variable, power and numbers. Students, all these are called polynomials. Understand the basics and mathematics become easy. Now let us understand each part. Students, now we are going to understand coefficients. Look carefully at this polynomial. X square plus 3x plus 2. Focus on the middle term 3x, which is the variable, that is x. Now tell me which number is attached to x. 3. Coefficient means the number that is multiplying the variable. So in 3x, 3 is the coefficient and x is the variable. Now look at the example 1, 5x square. Here 5 is multiplying x square, so the coefficient is 5. Now look at example 2, minus 7x. Here minus 7 is multiplying x, so the coefficient is minus 7. Coefficient means number that is multiplying the variable. Students, whenever you see a number attached to a variable, that number is called coefficient. Students, look carefully at this polynomial. X square plus 7x plus 10. This polynomial has two important secrets. The first secret is its coefficient. In this polynomial, the visible numbers are 1, 7 and 10. These are the coefficients. The second secret is its zeros. The zeros are hidden value of x. For this polynomial, the zeros are minus 5 and minus 2. Students, coefficients are variable, zeros are hidden, but mathematics connects the visible coefficients with the hidden zeros. Today we are going to discover how these two secrets are connected. Once you understand this connection, exercise 2.2 become surprisingly easy. Visible coefficients secretly control. Students, look carefully at this polynomial and I want to show you a hidden secret. First, look at the first coefficient and the last number. Here the coefficient of x square is 1 and the last number is 10. Multiply them. 1 into 10 become 10. Now our goal is find out two number. Those product is 10, sum is 7. But how do we find those two numbers quickly? Student, you see this equation, that is x square plus 7x plus 10. The whole expression is polynomial. What we have to do now, you see this first term, that is x square, and the last term is 10. You take out the first term, coefficient of first term, x square coefficient is 1. So I take 1 and the last number is 10. The first step is 1 multiplied by 10, that is the product of 10. What is the next step? We take out prime factorization of this product 10. So that is 2 multiplied by 5 and 5 ones are 5. So the factors are 2 and 5. So we discovered 2 and 5. We didn't guess 2 and 5. Let us verify what is 2 and 5. 2 and 5 are the factors. If you multiply this 2 and 5, you will get this product 10. That is our last term. And if we add the same factors 2 and 5, we will get sum. This is the middle coefficient of 7. Students, today our work is very simple. The step 1 is identify the polynomial. You see x square plus 7x plus 10. The entire expression is a polynomial. So the second step is identify the coefficient. See, this is the polynomial x square plus 7x plus 10. See, x square, what is the coefficient of x square? If there is no coefficient, we will consider 1 is the coefficient. So 1 is the coefficient of x square and 7 is the coefficient of x and the last term is 10. This is the second step. First step is polynomial. X square plus 7x plus 10. The entire expression is a polynomial. In this expression, 1 is the coefficient of x square. Identify the coefficient. 7 is the coefficient of x and 10 is the last term. The third step is finding the zeros and the fourth step is the relationship. The relationship formula, very simple. Alpha plus beta equals minus b divided by a. Alpha and beta equals c divided by a. We will understand step by step, students. Please follow the roadmap. Polynomial become easy. Step 3. What is a zeros of a polynomial? Students, polynomial machine. A polynomial is x minus 2 is a polynomial. Right, student? This is input, right? This is processing and this is output. What is a polynomial? X minus 2 is a polynomial. If I put 1 as the value of x, that 1 minus 2 become minus 1. What is the output? Minus 1. Is it a 0? No, not a 0. Then if I put x value become 3, that is x minus 2 equals 1. What is the output? That is a plus 1. Is it a 0? Not a 0. Then what if I put the value of x become 2, then 2 minus 2 is 0. Now the output is 0. This is called zeros of polynomial. Students, be careful. What is a polynomial? X minus 2 is a polynomial. This is minus 2 and this is minus 2 is already exist. We are just changing the value of the x. Value of the x, I put 1 in a first. Then 1 minus 2 become a minus 1. It is not a 0. Then value of the x I change 3. 3 minus 2 become a positive 1. It is not a 0. Then I changed x value become a 2. Then 2 minus 2 become a 0. Output is 0. So the zeros of polynomial means output becomes 0. See, input, polynomial and output. When output becomes 0, the input value called, whatever the input value, this is input value. This input value we call zeros of polynomial. Students, very important. First you need to understand what is polynomial. Polynomial is x minus 2 is a polynomial. What we inserted input, this 2 is input. So the output is 0. When the output becomes 0, the input value, this input value is called zeros of polynomial because the entire polynomial become a 0. So that is the reason zeros of the polynomial. See, students, very careful. Variable become a 0? No. Coefficient become a 0? No. The entire polynomial becomes 0. This is a zeros of polynomial. This is very important concept, student. See, students, imagine a polynomial is a machine. The value of the x goes inside the machine process an output. If the output is not 0, then that value is not 0. But when x equal to 2, the output becomes 0. Therefore, 2 is called zeros of polynomial. Remember, a zeros of polynomial is the value of the variable that makes entire polynomial equal 0. Polynomials. Before learning polynomials, we must understand one important thing. Every big building starts with a foundation. Every tree starts with a seed. Every chapter starts with basics. If basics are strong, mathematics becomes easy. If basics are weak, even simple problem become difficult. Therefore, today we will first understand the foundation of polynomials. Strong basics builds strong problem solver. Students, story of polynomials. Imagine a small plant growing. Day 1 10 centimeter, 2 15 centimeter, 3 20 centimeter and day 4 25 centimeter. What do you observe? Yes, it is increasing. Whenever the number changes in a pattern, mathematics creates a rule. That mathematical rule is called a polynomial. So, number that follow a pattern can be written using variables and powers. That mathematical rule is called polynomial. Now, students, understand a polynomial. Here 2x, this complete 2x is a polynomial. It is a polynomial. In this, there are two parts. Number part. The number part is 2 and the letter part is x. Student, look carefully. This expression has two parts. Number part is 2 and the letter part is x. Together they form one term. This is called polynomial term. So now we need to understand what is variables. Say 2x, it is a one polynomial, right? What is variable here? X is a variable. X is a variable. Why it is variable? A variable is a letter whose value can change. Sometime x value become 1 and sometime x value become 5 and sometime x value become 100. Value is changes. So that's why x is called variable. Now we will understand what is coefficient. Very simple, students. You see 2x, the whole expression is a polynomial. In this, 2 is the coefficient and x is the variable. Students, the number attached to the variable is called coefficient. What is term? See, students, 2x, this entire expression is polynomial, right? 2 and x, the coefficient is 2, x is variable. The 2x, when coefficient and variable, what is coefficient? 2 is the coefficient and x is the variable. When coefficient and variable come together, they form a term. So 2x is one term, coefficient plus variable together is term. Now students, types of polynomials based on terms. First, I need to understand terms. Say, this is 2x, the whole expression is polynomial. 2x plus 3, the whole expression is polynomial. 5x square minus 2x plus 3, whole expression is polynomial. But in this polynomial, there is only one term. So on base of one term, it became monomial. In this polynomial, there are two terms, 1 and 2. On base of two term, it became a binomial. In this polynomial, 5x square is one term, 2x is another term, 3 is another term. Total terms are 3. On base of this become trinomial. Now, we classify polynomials based on number of terms they have. Now, this is activity. Students, this 2x is polynomial, 2x plus 3 is a polynomial, 5x square minus 2x plus 3 is polynomial. In this polynomial, one term, so that's why it is monomial. In this two terms, so that's why it is binomial. In this term, there are three terms, so that's why it is trinomial. Students, now degree of polynomial. It is the most important concept, degree of polynomial. So what you have to see, first you understand definition. The highest power of the variable. This is the major part. The highest power of the variable. In this polynomial, x is the variable. Here also, x is the variable. In this polynomial, x is the variable. Students, only concentrate on variable. So, example 1, 2x. What is the variable? X is the variable. What is the power of that x? If there is no power, we will consider 1. If the power is 1, on base of power, degree is 1. If the degree is 1, that polynomial become linear polynomial. Example 2, x square plus x plus 1. The whole expression is polynomial, right? See the degree of polynomial, that is variable. Variable is x. So here in this x is, the power is 1. This x power is 2. Which is the highest power? 2 is the highest power. On the base of highest power 2, if the power is 2, quadratic polynomial. And see this polynomial, that is x to the power of 3 plus x square plus x plus 1, the whole expression is a polynomial. In this polynomial, we just see only the variable. Variables are x. What is the highest power of variable x? That is 3. If the highest power is 3, then that polynomial become cubic polynomial. Degree of polynomials, degree 1, see just a variable. Variable is x. X, the power is 1. If the power is 1, that is a linear polynomial, like this, 1. So, in this polynomial, x to the power of 2 plus x plus 1, the whole expression is polynomial. The variable x, the power is 2. If the power is 2, that is a quadratic polynomial. In this polynomial, x to the power of 3 plus x square plus x plus 1, highest power is 3. If the highest power is 3, that is called cubic polynomial. Next is zeros of polynomial. 2x minus 4, students, the entire expression is called polynomial. To find 0 and make polynomial equal to 0, I just take this 2x minus 4, I put equal to 0. See how to solve this question, it's very simple. 2x minus 4 equals 0. See this minus 4, if I bring LHS to RHS, then this minus 4 become plus 4. This is 2x equals 0 plus 4. 0 plus 4 become 4. Now, the second part is, see, this is x equals 4. See, this is 2 is the coefficient of x. If this coefficient 2, if I take from LHS to RHS, this become division part. Then 2 1s are, 2 2s are. So that's why x is 2. Therefore, 0 equals 2. 0 is the value of variable. Variable is x. That makes the polynomial. Polynomial is this one, 2x minus 4 equal to 0. 0 is the value of the variable that makes the polynomial equal to 0. Today you learned variable, coefficient, term, monomial, binomial, trinomial, degree and zeros. Students, when we classify a polynomial based on terms, we count number of terms. When we classify a polynomial based on a degree, look at highest power of the variable, and that is the foundation of entire chapter. If the foundation is strong, the rest of the chapter become very easy. In the next class, we will explore zeros of polynomial in depth and solve NCERT and CBSE equations. Let us begin with some real life question. Students, suppose I draw a road. Now imagine a car is traveling on that road. One question, at which point will the car touch the ground? Now imagine a rocket coming down. At which point will it land? Now imagine an engineer build a bridge. At which points will the bridge meet the ground? All these questions are asking the same thing. We are intended in points where the curve meet the ground x-axis. Exercise 2.1, question number 1. The graphs of y equal polynomial x are given in a figure 2.10 below. For some polynomial x, find the number of zeros of polynomial x in each case. Students, mathematics is more than counting. It is understanding. Students, many of you already count the zeros. You look at the graph, you count how many times it touches or cuts the x-axis, and you write the answer. That's correct. But mathematics is not only about counting. Understanding the zeros help us solve a real life problem in engineering, science, business and technology. Yes, this is exactly the problem. Most students learn the procedure, but they don't know the importance. Most of the students learns graph touches the x-axis 3 times, therefore 3 zeros. They can answer the exam question, but they don't know why those points matter. You should understand, zeros of polynomial are not just points on a graph. They are important decision-making point in real life. Why zeros are important? In engineering, they tell us where the bridge touches the ground. In science, They help scientists find the important points and events. In business, they show the profit or profit growth becomes zero. In technology, they are using in games, design, animation, and many simulations. Zeros of polynomial equals x coordinate of the point where the graph touches or cuts the x-axis. So finding the zero is not just a step in a maths. It's a tool to understand and solve real life problems. Imagine you are an engineer. Suppose an engineer is building a bridge. He writes an equation that describes the bridge's curve. The most important question is, where will this curve touch the ground? Those touching point are zeros of the equation. Golden rule for students. Zeros of polynomial equals x coordinate of the point where the graph touches or cuts the x-axis. Now the point is, what is x coordinate? Student, first let us understand what an x coordinate is. Look at the x-axis carefully. Every point on x-axis has a number. On the right hand side, we have positive numbers such as 1, 2, 3 positive number and so on. On the left hand side, we have the negative numbers such as -1, -2, -3, -4 and so on. These numbers that show the position of a point on the x-axis are called x coordinates. In short, every point on x-axis has the form where x is its coordinate. So zeros of polynomial equals x coordinate of the points where the graph touches or cuts the x-axis. Hello students, now we are going to solve exercise 2.1. In the 2.1 we have only one question which have 6 parts. The graph of y equals px are given in a figure 2.1 below. For the sum polynomial px, find the number of zeros of px in each case. See, this is x-axis and this is a polynomial line. Now students, you see this question. The graph of y is equal to px are given. For the sum polynomial px, find the number of zeros of px in each case. See, in this part 1, this is a polynomial line and this is x-axis. In this case, the graph does not touch or cut the x-axis. So, number of zeros are 0. In the second one, see, this is the polynomial line and this is the x-axis. The graph cut the x-axis at only one point. This is only one point. So that's why number of zeros is 1. See the third one, this is the polynomial line and this is x-axis. The graph cut the x-axis at 3 point. See, this is first point, this is second point and this is the third point. So the number of zeros are 3. See the fourth point, very simple. See, this is the polynomial line and this is x-axis. The graph touch the x-axis at one point. This is the one point. So number of zeros is 1. In the fifth part, this is the polynomial line. Number of zeros are, see, this is 1, 2, 3 and 4. The graph cut the x-axis at 4 point, so the number of zeros are 4. The sixth, the graph touch the x-axis at 1 point. This is the 1 point, so number of zeros is 1. Students, now we are entering exercise 2.2. In exercise 2.1, we understood zeros from graphs. Now in exercise 2.2, we will find zeros by calculation. This exercise has two main questions. Question 1 has 6 parts. We will solve each part slowly, clearly and step by step. First, we will find the zeros, then we will verify the relationship between zeros and coefficients. So, students, let us start question 1. Till now, in exercise 2.1, we learned how to identify zeros from the graphs. We simply observe the graph and counted the point where the polynomial touched or cut the x-axis. But now we are moving one step forward. Today we are starting exercise 2.2. In this exercise, the graph is not given. So the question is, if there is no graph, then how can we find the zeros of polynomial? That is exactly what we are going to learn today. We will find the zeros using calculation. Not only that, we will also verify an important relationship between the zeros and the coefficient of a quadratic polynomial. Don't worry, we will solve every question slowly, clearly, and step by step. See this question. Find the zeros of following quadratic polynomial and verify the relationship between the zeros and coefficient. Students, look carefully. The given polynomial is x square minus 2x minus 8. The variables in this polynomial are x, and the highest power is 2. On base of highest power, degree is 2, so that's why it is a quadratic polynomial. Point number 1. Point number 2, look at carefully the first and the last term of this given polynomial, that is x square is the first term and the last term is minus 8. Then what is the coefficient of x square? That is 1. Because when no number is written before the x square, we take the coefficient as 1. So 1 is the coefficient of x square and the last term is minus 8. Then students, once we understood what is the coefficient of x square, that is 1, and what last term is minus 8. To find out the product, we multiply the first term 1 and the last term minus 8. Our product is minus 8. Once we found the minus 8 is our product, 2 and 4, that is 2 4s are 8. So that's why 2 and 4 are the factors of 8. Students, this is very important. Product, first term and the last term multiplication, then you will get the product, that is 2 and 4 is the factors. Once you find the factors, what you have to do? See, let us write the factors 2 and 4. How do you get this last term minus 8? By using 2 and 4 only. You can use the different sign. Then that is 2 multiplication of minus 4 equals minus of 8. That is our last term. 2 plus of minus 4 become minus 2, that is the middle term. Minus 2 is the coefficient of x. So you have to write like this. Perfect. We got last term minus 8 and the middle term minus 2 is the coefficient of x. Therefore, the required numbers are 2 and minus 4. Students, all steps are very important. The first one is finding the product, the second one is factors of that product, and by using that factors, how do we get the last term and the middle term? The required numbers are 2 and minus 4. Very important, keep in your mind, students. Once you found the required number 2 and minus 4, the half of the problem is solved. So given polynomial is x square minus 2x and minus 8, you'd simply write the first term x square as it is first term x square and the last term minus 8, last term is minus 8. You just only change the middle term of minus 2x. Instead, you write with the required number you found, that is 2x minus 4x. So you just change plus 2x and minus 4x equals 0. The next term is group the terms. That is, you group this one. X is common, so I take x out. So here the only one x plus 2. Right, I take 2 here. This x is already taken as a common. And you see this one, minus and this minus, I take minus. 4 ones are, 4 twos are. I take 4 as a common and minus 4 is a common. Then x I take it here and 2. See, be careful. If I take a minus outside of the bracket, the inside become plus 2. This is very important, students. Take the common factor of x plus 2. This x plus 2 is a common, that is x plus 2, and x minus 4 is x minus 4 equals 0. Then what you have to do, students? X plus 2 equals 0. You take this 2 LHS to the RHS, that is 0 minus 2, 0 minus 2, that become x is equal to minus 2. And what about this? X minus 4 equals 0, that is x is equals 0. If I take this minus 4 LHS to the RHS, that become a plus 4, then x is equal to 4. So students, x minus 2 and x is a 4. So alpha is 4, beta is minus 2. Students, what you have done, you take the product and factors. With the help of product and factors, you found the required number. With the help of required number, you splitted the middle term and you found alpha and beta. The next is verify the relationship, sum of zeros. Students, you see this. Alpha plus beta equals minus b divided by a. The standard form is a square plus bx c. So what is the b value? B value is minus 2. What is the a value? The coefficient of x square, that is 1. What is the c here? 8. Right, student? It is a, it is b, and it is c. Right, students? You just write what is alpha. Alpha is 4 and beta is minus 2. 4 and minus 2. What is the b value? Minus of 2. This is minus of 2. And what is the coefficient of a? 1. See, students, you simplify it. 4 plus minus of 2 is positive 2 equals 2 minus cancel, that become a plus. So 2 divided by 1, it is always 2. So both the side is equal, so that's why it is verified. The next step is a product of zeros. Very simple, students. That is the formula. You apply the formula. Alpha multiplication of beta is equal to c divided by a. Alpha is 4 and beta is minus 2. So 4 minus 2 is equal to minus of 8. What is the c here? C is 8. Which 8? Minus 8. So I take minus 8 divided by what is the value of a? Value of a is the coefficient of x square, that is a 1. So minus of 8 divided by 1, which you know that is a minus of 8. Both the side is equal, so that's why it is verified. Very simple question 1.
10 Mathematics.